Okay, so I'm going to go through the homework quickly, and it's really important if you're not understanding what I am saying that you have to ask, because if you can't get this, then when we move on to balancing equations, it's never going to happen. So if you need to have the rules open in front of you and going backwards and forwards, please do. It's really important that you show your examiner that what is your final answer for an oxidation state. So in this one, this is the start, the way in, because potassium is group 1, its oxidation state will never change, so that will stay at +1, which makes bromine -1. Now, bromine lives in group 7, it has a -1 oxidation state anyway, but bromine's oxidation state can change depending on what it's with, okay, because the halogens can act funnily. So that would be how you would show your examiner. You can highlight it, doesn't matter, but some way that they know what your oxidation state is. So you don't have to work out electronegativities. That was just to show you how we're getting those numbers. So oxygen will always have a -2 oxidation state. Because I have 2 of them, that has to be -4 overall on this right side, which means the carbon has to be +4 oxidation state. So I've highlighted for my examiner this and this in terms of my oxidation states. For the PO4 3-, there's a rule for this, and the rule says you have to have this 3- left over. So oxygen stays at -2 always. I have 4 of them, makes it -8. I have to have 3 negatives left over, which must mean this side overall has to be -5, which means the phosphorus has to be +5. So this is because there were 4 O's, and this is because there must be 3 negative left when I'm done. Okay, so if there's any questions you need to ask.
Miss,
Yep.
where did you get positive phosphorus?
Okay, you need to...
Where did you get the +5 from?
Where did I get the
+5.
So when you've worked out what this part here has got to equal 0, just as this part here, so if we have the +5 for phosphorus, this part here has to be, when you do the maths, it has to be -3 left over, which we're getting from up here. So what I've done is the oxygen is the way in because it's always going to be -2. And I worked out down here that it's -5 because I have to have -3 left over. So if this side of it is -5, the other side has to be +5 for that to add to 0. Does that make sense?
Miss, when do you know when you have to have things left over?
Because it'll have this part up here will be in your equation. It'll be a complex ion, and it will be left over. And there's other questions that we'll do later where, by knowing that the whole lot of this is -3, it can help you to figure out stuff. So that's why knowing your complex ions can help. Okay, we then went on to this. So this was something we did when you were in Form 4 when we were doing our naming. If there are Roman numerals given in a name, then you can get the oxidation state from it very easily. So this says it's iron 2 oxide. So that means that the iron in this is Fe2+. But you can prove it to yourself. So FeO, oxygen is always -2. That's the way in. It must mean the Fe over here has to be +2 for both of these to equal 0. Okay, similarly down here for the iron 3, it has to be Fe3+ because it says iron 3 in the name. And just to prove it, Fe2O3, oxygen is always -2. I have 3 of them, it's -6. This must mean the other side has to be +6. And because I have 2 irons, each iron must be worth +3. So you can get it from a name if you have to, but you can always work it out. Now, we said when we went through our rules that chlorine is weird. So again, from the names, you can get the oxidation state of chlorine in these, but you can also work them out. So the oxidation states are going to be +1, +3, +5, +7. I'm just going to take this one here and just show you how you would work it out. So I need to, each oxygen is worth -2. There are 3 of them -6. I have to have this negative left over when I'm done. So this side has to be -5, which must make the chlorine to turn this into 0 +5, or to turn this into -1. But either way, chlorine is +5. Is there any questions?
Can you go through that one again, please?
Yep. Okay, so oxygen always -2. 3 of them makes it -6. Because this negative is here, I have to have that negative left over. So by making this -5, I've now that one negative left over. It won't be cancelled out. So if this whole right side is -5, then the other side has to be +5, because these two numbers together, when you add them, they add to 0. If we put the +5 in here and we add these together, they leave us this -1 up here. So you have to take, if they give you a charge, you have to take that into consideration. But this is the oxidation state of chlorine in ClO3-. Are we happy? Okay, so you had to do these guys. We come back to them. I think did I move them? Oh, it didn't upload. I had changed it all. Okay, so here is HNO3. You only have to find the nitrogen in it. So if you can work it out, you can just leave the +5. I personally would always work it all out. So oxygen is -2. Hydrogen will always be +1 unless, hydrogen is always going to be +1. But over here for my oxygen, it's -2 oxidation state. I have 3 of them, it is -6. So what do I have to put in over on this side to make sure that this left side over here is going to be +6 in total? So that must mean the oxidation state of nitrogen is +5, because these guys add up to +6. This guy is -6, and when you add those together, they both turn into 0.
So is it only ever the left-hand side and the right-hand side? It's not like you wouldn't put 3 kind of columns for H, N, and O?
No. Usually what's negative is on the very right, and usually what's positive is on the left. So just to go back to one of the exceptions for oxygen is when it's with fluorine, because fluorine is the most electronegative thing. So fluorine is always -1. There's 2 of them, it's -2. Oxygen in this case must be +2. So the plus is always on the left hand side and the minus is always on the right. And usually the rule would be you will have more things that are positive than you will. There will always nearly only be one thing negative. But you could have, like you have over here for the HNO3, you have 2 things that are positive. So negative is always on the right hand side. So here for MnO4, it's oxygen is always -2. There are 4 of them, makes it -8. I have to have this one left over, so I make this -7, and then the other side has to be +7 for this to add up to 0. And if I put +7 here and add this up, I end up with my -1 overall. So that is my oxidation state for manganese. So we go over to this side for the S2O3. So now I have 2 negatives going to have to be left over. So -2, 3 of them, -6. To have 2 negatives left over, this must be -4, which makes overall on this side +4. which makes, and because I have 2 sulfurs, each sulfur is worth positive 2. Any questions? So we have a look at the Cr2O7. No. So Cr2O7, 2 minus. So oxygen again, minus 2. I have 7 of them, minus 14. I have to have 2 left over, negative 12. Which means this side must be positive 12 in total, and because I have 2 chromates, positive 6. And for the VO2 plus, so this is rare, but it does happen. So this is negative 2. To have 2 plus left over, the other side has to be positive 4, because when I take positive 4 and add negative 2, I will end up with 2 positives.
Miss, you do that last one again.
The last one again. So we've said that, so we always look at the oxygen as long as it's not in a peroxide. So this is where you have to know your rules. So oxygen is always negative 2, but I have to have 2 positives left over. So the only way I can get 2 positives left over is if this is plus 4. Because if I just left this as negative 2, and if I decided this was positive 2, when I add those up together, that would give me 0. But if I add negative 2 and plus 4, I will be left with positive 2. So I have to add on more positives than negatives to make sure that I am hitting the charge, because this has got to be left over. So there was 2 more that you had to do for homework, and these were the top 2. So there's 2 ways that you can approach this. If you know that this whole thing as a complex ion is negative 1 overall, you can use that to help you figure out some stuff, because straight away it makes this positive 1, the sodium positive 1, and then you can use the fact that this is negative to work out what your NO3 is. So I'm going to do it both ways. I'm going to do it the way that says I just take it as NaNO3, and I know from my rules that this will be minus 2, and I know that this will be plus 1. I know over here with my oxygen I have 6 of them, or sorry, 3 of them, so 3 negatives 2s is negative 6, which must make this whole thing over on this side positive 6. And to find out what the N is, I need plus 5. So that's just doing it from the formula. But if you decided you were going to go Na is plus and NO3 is minus, so then this is plus 1, minus 2, I have 3 of them, minus 6. I have to have 1 left over, minus 5. It must mean this has to be plus 5. So it doesn't matter which way you go at it, you should get the same outcome.
How do you know that Na was plus 1?
Because if the go back to your rules, and the rule is if you're in group 1, you have a positive 1 charge. Group 2, positive 2 charge. So group 1 will always be positive 1. So again with the NaNO2, you can either go about it that this is a negative 1 by itself, because you know what the complex ion nitrite is, and again that will make this positive 1. So the 2 ways you could go about it are NaNO2. So minus 2, I have 2 of them, negative 4 in total. I know my sodium over here is positive 1. to make this add up to 0, my nitrogen has to be positive 3. Or I can do it, separate it out and decide this is positive 1, and now I'm just looking at this. So I have minus 2, I have 2 of them, minus 4. I need 1 negative left over, minus 3. It must make the nitrogen over here plus 3. So it doesn't matter which way you go at it, you will get the same answer. Now, so that brings us to today, page 111. So you're not going to name, it's page 111 on mine, you have the chlorine here, you have these guys, and these guys. You're not going to name them using Roman numerals for me, you're just going to tell me what the oxidation states of things are. Okay, so we'll give you 7 minutes. It's 13:15 now. I'll give you 7 minutes to get those 1, 2, 3, 4, 5, 6 done. Okay, folks, do we seem happy enough to move on? I'm trying to look at you and can you give me thumbs
Yeah.
up? I can see loads and loads of you. Alright, so the rule is for an element, the oxidation state is always going to be 0. So chlorine over here is going to have an oxidation state of 0. For carbon dioxide, carbon, oxygen is -2. I have 2 of them, -4. The carbon has to be +4. For calcium hydride, the rule is calcium or hydrogen will always be the +1. I am correct to say that now. Yeah, except in your metal hydride when it's the other way around. So this, yeah.
Sorry, I was getting the oxidation numbers, but like, what do you mean by the oxidation state? Is that a combination of the two?
Same thing. They're interchangeable. Interchangeable.
Miss, what's CL2?
Cl2 is an element. It's just chlorine, and the rule is for an element it will always be a 0. So if you had just copper in an equation or copper in a formula by itself, that is an element. So these guys have oxidation states of 0. So that is one of the rules, and you just have to learn it and apply it. So again, we've said everything that's ever going to be negative is going to be on the right hand side. This is an exception. Hydrogen is usually +1, except when it is in a metal hydride, which this is, calcium hydride. So -1, I have 2 of them, -2. Calcium is +2. And calcium also, because it's a group 2 metal, will always be +2. So you can work it from that way. For your versions of bromine, so it is -2. I have 3 of them, -6. I have to have this negative left over, +5, or sorry, -5. So the bromine over here has to be +5. For the BRO minus, it is -2. Oxygen, I have to have 1 left over, so -1. It means this bromine is +1. And for the BRO4 minus, oxidation state of oxygen is -2. I have 4 of them, -8. I need to have 1 left over, -7, which makes this bromine +7. Ooh, no wonder I can't see properly. So how are we feeling on those? Think we're happy? Okay, the last part of this is here. No, it's all going to repeat. I cleared all these and yet here they all are again. Is this part. So you have to work out, is it oxidation, is it reduction, or is it neither? So you have to work out, so I'll do the first one with you. So NO3 minus goes to NO. So I'm starting on here. If oxygen here is -2, nitrogen must be +2. Over here, oxygen is -2. I have 3 of them, -6, and I have to have 1 left over because this, -5, my nitrogen must be +5. So yesterday, or was it yesterday's homework? When you are doing the square brackets to show oxidation or reduction, you have to link them together. So it has to go from N to N. It can't go from N on the left to O on the right. You're linking those parts, and you have to use the oil rig and my silly one of OIR and RDL. So straight away, this is a decrease in oxidation number. I'm going from +5 to +2. So that is a decrease in oxidation number. This makes this reduction. Okay, so you need to think about a number line for yourself. And here is 0, and here is positive, and this is negative. And if you're going from +5 to +2, that is a decrease in oxidation number. That is reduction. So we'll give you, it's 13:25. Give you about 8 or 9 minutes. I'll know by your heads. Just sit back when you're done and shout if you need help. Okay, I'm gonna start going through them so we can give you a break. So HNO3 to N2O, minus 2 minus 6, always going to be plus 1, so this must be plus 5, minus 2, this has to be plus 1. So nitrogen is going from plus 5 to plus 1, that is a decrease in oxidation number, that is reduction. CH4 to CO is a negative 2 and a positive 2 for your carbon monoxide. This is going to be negative 1, there's 4 of them, negative 4, this is plus 4. So my carbon is going from plus 4 to plus 2, that is a decrease, makes this a reduction. MnO2 goes to Mn2 plus. So for the Mn2 plus, it is the rule, if it's a simple ion, then it just gets the charge. So over here, this is negative 2 for oxygen, 2 of them, negative 4. It must make the manganese plus 4. Manganese is going from plus 4 to plus 2. It is a decrease. It is a reduction. Cr2O7 2 minus, going to Cr3 plus. The Cr3 plus keeps its oxidation state of plus 3. It is minus 2 for oxygen. There are 7 of them, minus 14. I have to have 2 negatives left over, minus 12. It makes this side plus 12. It makes each chromate plus 6. So chromate is going from plus 6 to plus 3. That is a decrease in oxidation number. It is a reduction. SO3 2 minus goes to SO4 2 minus. It is a minus 2. I have 4 of them, negative 8. I need to have 2 left over, negative 6. It makes sulfur here plus 6. On this side, oxygen is negative 3. Negative 2. I have 3 of them, negative 6. I have to have 2 left over, negative 4. It makes this plus 4. My sulfur is going from plus 4 to plus 6. That is an increase in oxidation state. This is oxidation. For my Cr2O7 2 minus goes to Cr04 2 minus. So over here, oxygen is minus 2. There are 4 of them, negative 8. I need to have 2 left over, negative 6. It makes the chromium here plus 6. Here it is negative 2. I have 7 of them, negative 14. I need to have 2 left over, negative 12. It makes this side positive 12, and because I have 2 chromiums, each chromium is plus 6. So this is going from plus 6 to plus 6. It is neither a redox or it's not a redox. There's nothing oxidized and nothing reduced. So I'm just going to delete some of these. So I have left H2O2 goes to H2O. So over here the oxygen is negative 2, each hydrogen is plus 1. H2O2 is a peroxide, so the rules in a peroxide is oxygen is minus 1. I have 2 of them is negative 2. Each hydrogen together is worth plus 2, so each hydrogen is positive 1. So here it's going from oxygen to oxygen. It's going from minus 1 to minus 2, which is a decrease in oxidation number. That is reduction. And the last one over here, H2O2. So O2 is an element. It's always going to be a 0 for its oxidation state. And again, this is negative 1. I have 2 of them, negative 2, plus 2, plus 1. So here I'm looking at my oxygen. It's going from minus 1 to 0. That is an increase in oxidation number. That is oxidized. How did we get on?
Miss, is oxygen not always a minus 2 charge? Why is it minus 1?
So there is, if you go back to your rules on page 108 where we've written in oxygen, there are 2 exceptions to oxygen. One is when it's a peroxide. H2O2 is a peroxide. It's really the only peroxide that we have on our course. And the other exception is when oxygen is with fluorine.
No, I just meant to know that it's a peroxide or...
Yeah, you were meant to know H2O2 is hydrogen peroxide. So if you, it's really the only peroxide that I can remember seeing on a Leaving Cert course. So they are 2 rules you have to know. Okay. Go, Mikey. I'm going to leave you. Turn off your cameras. I've sent private messages to Gerald, to Miles and Charlie. I'll reply to you now. So turn off your cameras, turn off your volume and come back to me at 13:45. Go have a break.